Hi there, this lesson video is for our final look at some fractions. Remember, we've done partial fractions, but we've also done some other types of fractions. So linked in with this as well was a bit that was on the factor theorem, which I suppose is the start. I mean, factor theorem is all really about division, so I can see why the books put it together for convenience sake as a reminder. So just before I go, just a reminder then of there are two types really that we're looking at. The basic ones where you just have ax plus b, cx plus d on the bottom. So two different factors, and they're both linear factors, and that's the critical thing here. And you just put a over 1 plus b over the other. The one that I want you to look out for is either version of this one. It doesn't really matter which one you look at. Because you have what's called a repeated linear factor, i.e. it says squared in both examples, you'll notice on this one it's cx plus d squared, so you end up with a b over cx plus d and a c over cx plus d squared. Here it was the ax plus b that was repeated, so therefore you get a over ax plus b over the square thing as well. And that form where you get two versions for the repeated factor is what I want you to look out for. So a few questions then based on this. Find the quotient and the remainder for this when it's divided. Oh, right. So if we're going to have to divide, there's no way around it really. So 2x squared plus 1, and we divide it into what we divide 4x cubed plus 8x squared minus 5x plus 12. And so part of exercise 5a was all about algebraic division, so this is no different from that. What do you times 2x squared by to get 4x cubed? Well, obviously it's a 2x. 2x times that is 4x cubed, which is why we did it, plus 2x, and my famous phrase is put it in a bracket to remind you to take away. Now, one thing actually I don't like here, and I'm going to rewrite this in a bit, is notice the way this is done is the 2x times 1 is giving me 2x, and it doesn't line up with the x squared, so actually I'm going to cross that out and put it there as a plus 2x there. Now that is a much better place to put it. So when I take away, they're now in columns, so the x cubed cancel. The 8x squared minus nothing is still 8x squared. And minus 5x minus the 2x is minus 7x. And I'm going to bring the 12 down as well. What do I times the 2x squared by to get that? Oh, well, I reckon times by 4. 4 times 2x squared is 8x squared. And again, leave a gap because it's plus 4 when I do that. Put it in the bracket to remind me to take away. I reckon I get minus 7x, 12x, plus 8. So I reckon here the quotient, now the quotient is the bit at the top. That is the 2x plus 4. And the remainder is the bit at the bottom. What you're left over with, is minus 7x plus 8. So we haven't seen it written overly like that before. Don't know where that answer came from. It obviously wasn't the right one, but that's the right answer. Second, now this is a partial fraction. So it tells us this can be written like this. Now this is a bit kind really. It doesn't expect us to remember, it just tells us it. So that's nice of them. So they're saying 2t, change a letter, usually they're x's, but other than that it's the same, is identical to a over the first one plus b over the repeated one. And you recall that what we tried to do is we tried to write the right hand side over the t plus 1 squared. So if I just put it over t plus 1 squared, then the a has had to be times by t plus 1 to make it work, but the b was already over it, so we didn't change it. And you will recall that I quite like to not bother writing the bottom out. So set t equal to minus 1, because that will make this bracket equal to 0. So the left hand side is minus 2. That disappears, and that equals b. So I now know b already. Pick a value. I told you last time to use t equal to 0. Now if I use t equal to 0, the left hand side gives me 0. Now it gives me a times by 1, so that's just a plus b. Now b, of course, I know is minus 2. So that gives me 0 equals a minus 2, and I reckon a therefore is 2. So my constants now are 2 and minus 2, so that's how I now know where the answer came from for the last question. Third one, right, this looks like a factor theorem question. Now it reminds us of this rule that says if I've got a function and I divide it by x plus 2, then I can actually put the minus 2 in. That's not technically on our syllabus now, but you might as well see it. If I put minus 2 into this, that becomes 12 minus, plus 44, plus 9 times 4, minus, what's minus 8? So it's minus a minus 8, so it's actually plus 8. So it's actually a huge number when I put minus 2 in this. And we get, that's 36, that's 44, that's 88. I reckon that's 100. There you go. So that's just the remainder theorem, which we haven't really seen before, but it tells you that. And the point about this, of course, is what we want is the remainder to be 0, because when the remainder is 0, you get a factor. So we are looking on this example when it says show that the remainder, there is a factor. We want the remainder to be 0, f of x equals 0. This is what we've seen. Now, of course, if I put 3 in here, it will make it work. So if I do f of 3, when I say make it work, that will make that bracket equal to 0. So if I put 3 into this, I get 12 minus 22 3s are 66, plus 9 times 3 squared is 9, minus 27. And I'm going to do that on my calculator just to make sure. I've got 12 minus 66 plus 81 minus 27. It does equal 0. And because it is equal to 0, therefore 3 minus x is a factor. So now it says express as a product or a linear and a quadratic factor. So this is long division. Now the one thing I don't like about this is everything's kind of written in a funny order, I mean in both cases actually. So I'm rather than writing 3 minus x divided into this, which I mean it would be tempting to write 3 minus x, and I've got to divide that into my horrible expression, etc. But I just don't like the order it's written in. So I'm going to just change it, and I suppose you could do it without it, but I think I prefer it as minus x plus 3. And that's got to be divided into, what is it? It's minus x cubed plus 9x squared. You'll notice I'm just putting it so the highest power always comes first. You don't see very many of these in the wrong order, but it just goes to show that you can throw something at you just to annoy you. So minus times a minus, well, it'd be a positive when I do that to get the minus. So if I times minus x by positive x squared, I get minus x cubed. So I'll times it out, I get minus x cubed plus 3x squared. Put it in a bracket to remind me to take away. That will disappear. 9 minus a 3 will give me 6x squared minus the 22x. Now what do I times minus x by to get 6x squared? I reckon that's minus 6x. Minus 6x times that is 6x squared, and then minus 18x. Put it in a bracket to remind me to take away. That disappears. Minus 22 plus 18, I reckon, is minus 4x. What do I times minus out? That's plus 4. And that does indeed give me minus 4x plus 12, which is nothing left over. So when it says write it as a product of a linear, so I can write f of x then, is equal to the original 3 minus x, and it's times by x squared minus 6x plus 4. And you'll notice all I've done is I've written this thing, written the other way round, but this is the same, times by this thing here, my quotient. Hence solve the equation f of x equals 0, given each root where appropriate. Well, this is really, well, I know one answer already, so when this equals 0, this bracket tells me the answer is x equals 3. And the other solutions come from this. So I'm going to put that into my calculator. I've got a menu A, quadratic equation solver, so polynomial degree 2, and it's 1x squared negative 6x plus 4, and it says it's x equals 3 plus root 5, and presumably the next one's 3 minus root 5 as well. Yes, it is, so I'm going to write 3 plus or minus root 5. There's my answers. So there's actually 3 answers there. Next question. It's a partial fractions question again. Now it's a bit different, this one, just looking at it. We express that in partial fractions, so it's x plus 8 over x plus 2. Interestingly, there's no repeated factors of these, so I can just write a over the first one plus b over the second one. So these are quite straightforward. If I multiply that out on the right hand side, or of course multiply and all that, I'll get a x plus 2 plus bx, and you should remember how to do that. Set x equal to minus 2. If I do that, the left hand side is 6. That disappears, and I get minus 2b, and therefore b equals minus 3. If I set x equal to 0, because there's no number next to it, on the left hand side I get 8, and here I get 2a, and this implies that a equals 4. So I reckon this equals, well, it's a over 4 over the x minus 3 over the x plus 2. Now, first using division, so it wants me to divide x, well, I'm going to multiply this out. This is x squared plus 2x. Again, get it into a nice format. Divide it into the 7x squared plus 16x plus 16. That's what it's asked me to do, use division. So what do I times the x squared by? 7. So that gives me 7x squared plus 14x when I multiply back again. Put in a bracket to remind me to take away. I reckon I get 2x plus 16. And that's interesting because what did I have originally? I originally was asked to do x plus 8 divided by this thing. And what this tells me is that my expression here is equal. Now I've got 7. It goes in 7 times. But there's a remainder, and that remainder is 2x plus 16 over x plus 2. And of course 2x plus 16 is twice what I've got up here. So I can use my result from just now. This is 7. It's double what I've got here and here. So I reckon it's 8 over x minus 6 over x plus 2. And I think they're the answers. That's what I've got the answers. Yes, they are. Good. I like that. Now, I'm just going to highlight this to you for a moment. This is what I want you to do. Mixed practice 5. And I'll then try and do one more question, perhaps show you a couple more. So page 105 is if you're using the textbook, otherwise used in the sheet. So here's another question. And write this in partial fractions. It looks like a fairly straightforward one. X over x plus 1, x plus 2. So they're not repeated, so that's a over the first one plus b over the second one. And when I do my cross multiplication, I'll get a x plus 2 plus b x plus 1, and that's going to be equivalent to x. So pick a number, x equals minus 2, because that will make that disappear. And it says x, so I can just write minus 2. That disappears. Minus 2, that gives me minus b. So therefore b equals 2. And if I do x equals minus 1, then minus 1 will equal, well, this time that one disappears. Minus 1 goes there. I reckon a times by 1. So a therefore is minus 1. So if I'm going to write this, it's going to be the a. So I might as well do that 1 second. Well, I guess minus 1 over the x plus 1 plus 2 over the x plus 2. Now the only thing if I was doing that, I would, oh right, I have written it like that. I would have probably written it the other way around. Here's another one. Now this will require you, and you're going to have to do this yourself. This will require some repeated factors. So just make sure you can do this, because it doesn't give you any clues here. But you're going to have to do a over the first one, that's fine, plus b over, well, 1 minus x, plus c over the 1 minus x squared. And you're going to need to remember how to do that. I'm not sure if they're the answers. I'm not convinced. That looks like the answer from the previous question, but have a go at it and make sure you see if you can do it. And this last one, again, they give you a clue of how to do it. According to me, they're the answers, but who knows? Remember, please, mix practice 5. Have a go at that, please. Thank you very much.